Welcome to today's webinar Wednesday. My name is Gabe Crisologo. I'm an applications engineer based out of our Mountain View, California office. And today we're going to be talking about SolidWorks CAM and CAM Professional, right? It's pretty much giving you an overview, kind of tell you what it is, show you a little presentation on how it works, right? So if you're not familiar with SolidWorks CAM, it's pretty much, it's not a new product. So it's pretty much powered by CamWorks. CamWorks has been around since around 97 or 98. One of the first CamWorks or SolidWorks Gold partners for the CAM space here. So CamWorks or SolidWorks CAM, it's fully integrated, rules-based, 2.5 axis milling and turning solution, again powered by CamWorks. So it's got the seamless integration. You have that full associativity. Right, you're creating your designs and models in SolidWorks. You make any changes to that, the Toolpath will automatically detect those changes and update as well, right? And it's got the, when I say rules-based machining, it's pretty much being driven by a database. So pretty much you can teach that database how you like to machine things. You can pretty much set all those feeds and speeds, different types of machining parameters. And the great thing with having that being rules-based in the database is everyone can pretty much program the same way across the board. So, you know, you got people in the shop during the day, in the evening, it's all using the same database, and everything is getting machined the same way across the board. Right? So a couple different things here that we're going to talk about. Of course, the SolidWorks CAM and SolidWorks CAM Professional, right? You can see here from this slide that there's a couple different options here. So with the SolidWorks CAM, that is the one that is included with all versions of SolidWorks. So whether it be SolidWorks Standard, Professional, or Premium, as long as you have an active subscription, you have access to SolidWorks CAM Standard. So here on the left in the green, you can see that you'll be able to pretty much program with individual parts. So you can program individual part files, throw some Toolpath on there, 2.5 axis parts. That's got the automatic feature recognition. If you've ever imported a part file into SolidWorks and it asks if you want to run that feature recognition, that's pretty much the technology that CamWorks or SolidWorks CAM is using to generate the toolpath on your parts. You also get access to the Universal Post Generator, NC Editor, and again, that knowledge-based or rules-based machining, the database that's pretty much the foundation of how the SolidWorks CAM runs. Right? With the SolidWorks CAM Professional, you can machine in assembly mode. So if you had your table, vices, fixtures, all that modeled up in SolidWorks, you could actually simulate that environment in the software and machine in the assembly environment there. It also includes 3+2 machining, so the 4th and 5th axis indexing or prepositioning, also turning, so I think 2-axis lathe and also high-speed machining. And you can see here on the right, with the full-blown CamWorks packages, you can get into more complex machining solutions here. So wrapped features with the rotary milling, sub-spindle operations on your lathe, 3-axis milling, mill turn solutions, so on and so forth. Right. So the agenda for today, we're going to be doing an overview of the SolidWorks CAM interface, show you how well integrated that is in the SolidWorks space here, and then we're going to go ahead and program a 2.5 axis part. I'm going to show you, since we're working in SolidWorks, you can go ahead and download and import parts from vendors and utilize those in your assemblies. Then we're going to show how to pretty much put that part and set it up in assembly machining, and then we'll go ahead and open it up for questions and answers here. So any questions that come up along the way, you can go ahead and start chatting in the questions box there, and I can go ahead and try to address those along the way. All right. So let's go ahead and let's get started here. All right, so we are in SolidWorks here, right? I got this part, and kind of taking a look at this part here, right? We are working in SolidWorks. You have the full feature tree for this, but it doesn't have to be a native SolidWorks part. You can use SolidWorks CAM's program parts that were imported as step IGES files, or utilizing 3D interconnect. You can go ahead and bring in, Creo files, inventor files, so on and so forth. So first thing we're going to do is go ahead and turn on the add-in. So under the Tools, Add-ins, you'll see SolidWorks CAM 2018. I'll go ahead and turn that on for this session. You can also check that box to have it start up with every SolidWorks session here. And once that loads, you will see not only this tab in the Command Manager, right? So you can see that here, SolidWorks CAM. You have all these tools. In the tree here, you'll also get the CAMWorks trees. So the SolidWorks CAM feature tree, the SolidWorks CAM operation tree, and the tool tree. So as we go through this here, we'll go ahead and talk about what each of these are. So again, you have the full on SolidWorks feature tree, and you have the SolidWorks CAM feature tree here. So this is where you would define the features that you want to machine: pockets, holes, bosses, so on and so forth. And for each of those features, you would have an operation to machine those features, and this is where those would show up, right? So if you're doing a roughing, finishing pass, that would show up here. Now the tool tree, this is pretty much your tool crib here. So you can set up a tool crib for each of your machines that you have lying around in the shop, or you can have the an overall tool crib for all the tools that you have in the shop, and have that full-blown list here, right? So as we go through this kind of programming this part here, if you're new to the CAM space, or if you're using a different CAM solution now, kind of wanted you to think about how long it's going to take for you with your current process to kind of machine or program this part here, right? And after you see the SolidWorks CAM, as we walk through this together here, right, I'll show you how easy it is to do in SolidWorks CAM. All right, so we'll go ahead and get started here. So in the SolidWorks Feature Tab here, we can see that there's a machine. It's got Haas VF1. This, if I double click on that, I can go ahead and choose my machines here. This is just a list of generic machines. If you wanted to, you can go ahead and load your own machines here in the database, right? So we can just go ahead and select that. You'll have a tool crib tab here to choose which tool crib you want to use. You also have the option to do tool crib priority. So for the part that you're programming, if you selected a tool crib, for example, you can say, look for this tool crib, or look for the tools to machine the part from this tool crib only, and it'll only pull tools from here. If not, then it'll, if it doesn't have the tool to cut the feature, it would look to the database and pull a specific tool based off the feature there and pull from the database, right? So that's what the tool crib is. Post processors, you can see we have a list of some generic post processors here, but SolidWorks CAM also comes with a pretty extensive list here of some post processors here as well. So you can see there's some generic VF3 posts, so on and so forth. Now, if you are not familiar with post processors, you can go ahead and give us a call as well. We do offer that as a service to pretty much customize the post to do exactly what you want to do there for your machines. Or if you're familiar with writing your post, you can go ahead and use the Universal Post Generator, or the UPG. And you can pretty much go through here and pretty much customize your own post. Right? So if you're doing like a generic FNUC controller, you can take a look at the sample code and see kind of what it's doing here. So if you're familiar with that, you can go through this and customize your own post and write all that here using all these parameters. All right, so I'll just go ahead and choose some generic stuff here. Say OK. All right, so now that we have the machine set, we can go ahead and define the stock. All right, so the stock, we can double click on anything in the tree here. You can double click on that or kind of work left to right here in the command manager. So I can click on the stock manager button here or double click on it or even right click and say edit definition. A bunch of different ways that you can access this menu here, right? So the material, you can load your own custom material in the material database, and that database pretty much controls, it's one of the ways that you can control the feeds and speeds. Right? Of course, if you don't see the specific material that you're working with there, you can create your own custom ones there as well. Right? Now, different ways to define the stock type here. Right, 4 different ways you can do that with a stock bounding box, and it shrinks the bounding box to the size of your part. And of course, you can go ahead and add additional offsets in the X, Y, and Z position here. Now, the X, Y, Z is going to be going off of the reference triad here that you see from the SolidWorks kind of global origin here. So the great thing with this is if you imported a part and it's kind of off axis relative to this here, you can go ahead and create an actual SolidWorks coordinate system in SolidWorks and reference that here to go ahead and readjust that, right? So yeah, full control over how you want to do that. So if you wanted to, you can go ahead and add additional offsets in the positive and negative X, Y, Z, and you can see how that stock automatically adjusts based off those here. Now, of course, when you're going through and adding additional stock, you want to take a look at the overall stock size here, because you know a lot of the times when you go and cut your stock or you're going to buy some blanks, it's not going to be these weird numbers here, right? So you can adjust these offsets to make sure you get some nice whole numbers there, nice round numbers. So that's the stock bounding box. We can also do this with an extruded sketch. Okay, so the great thing with this is you can sketch your stock in SolidWorks using the SolidWorks sketch tool. So if you have something cut from a laser or water jet, you can go ahead and sketch that up here. You can even use a sketch that you have for your actual part file that you want to machine. So of course, we're going to go ahead and just use that here, automatically have that cut to that shape. And then we can go ahead and say it's up to face. There you can even give it an additional offset if you want to add a face feature, right? So you can go ahead and do that, add additional offsets, so on and so forth. The next one is an STL file. You can go ahead and import an STL file here, or you could even have a SolidWorks part file with different configurations here as well. So if you kind of have like a work in progress that you're taking this piece to, setup to setup, you can go ahead and have different SolidWorks configurations for those and use that as a work in progress as stock for the next operation, right? So we'll just go ahead and use this sketch option here. We'll go ahead and say OK. All right, so our stock is defined, and we want to go ahead and define the coordinate system here. So a number of different ways you can do this as well. You can go SolidWorks coordinate system and define one in SolidWorks. And you can choose it from that feature tree, or you can go ahead and select it from the interface here. All right, if we go user defined, we can go ahead and choose an entity, or even go off the stock bounding box vertex. So if you had a square stock, you can go off the corners, the part bounding box, or you can even just choose an entity here, say you wanted to go from there, so on and so forth. Right, so you have full control over where you want to put that. And then say OK. So once that's set, the next thing we would want to do is create the setup, define the setup direction, and then go ahead and start programming this part. Now what I'm going to do here is do the extract machinable features. So what this is, it's doing the automatic feature recognition, and it's not looking at the SolidWorks features here, but it's looking at the actual geometry of the part. So this is why you're able to do this on imported part files or non-native SolidWorks files here as well. But it's taking a look at the geometry, and based off that geometry, it's going to look at that knowledge base for the rules-based machining, and depending on the size, right, it'll pull in a specific strategy on how to machine that specific feature and the tools as well. So it's actually pretty intelligent. It's not just like saying, hey, this is a size pull in this specific tool. It uses expressions, and you can kind of customize that as well as needed. Right. So let's talk about a little bit of the options here. When I actually go and hit this extract machinable features to run the automatic feature recognition, what that's going to do is take a look at the features that you want to cut here. So if you add additional stock on the top face, you can go ahead and add this facing feature and have it automatically detect that. So you can go ahead and do that here as well. So we'll just go do holes, non-holes, and the boss, right? And we'll go ahead and say OK. So I'm going to go ahead and do the automatic feature recognition and detect the machinable features here. Right, and here we go. So you can see that it detected the pockets, and when you hover over each of these, it dynamically highlights on the part here what those features are, groups like features as well for the holes, so on and so forth. Now, what you see here for the rough finish is the machining strategy for these types of features. So when I generate the operation plan, these are getting pulled from the database. So so when I go ahead and generate the operation plan, it's going to look at that specific rough finish strategy here and generate those operations to machine those features. So you can see here that for this regular pocket 1, it's got a rough finish strategy. That rough finish strategy is the rough and contour mill, which is the finisher, and those are all tied to the pocket 1 there. Right. So you'll also notice that it turned from kind of that pinkish color to the it's black here. So it's kind of like, you know, when you're thinking of your SolidWorks stuff like your sketches, whether it's like a defined or underdefined, so on and so forth. That's kind of like that here. So this feature pretty much has an operation tied to it, so it turns from pink to black. That's just letting you know and visually seeing this here, like, hey, this has an operation and it can be machined. Right? And then in the operation tree, you can go ahead and see all of these different operations for the different features here. And you'll see here, these are the tools that it's using to cut those specific features, right? And then I can go here and generate the toolpath. And just like the features turned from that pinkish to that black color, when you generate the toolpath, it'll generate the toolpath for all those operations here as well. And those will turn from pink to black, right? You don't have to generate the toolpath or operations for everything as a whole. You can do it by setup. You can do it by specific feature or operation as well, right? So you can go and right-click on any of these and generate toolpath, simulate them as well, right? So once you've defined the features, you can do that either automatically using that extract machinable features, or manually or interactively, as I say. You can just go and right-click on your setup, and then you can use this and say, define a 2.5-axis feature. Hey, this is a pocket. I want to machine this specific pocket here. The end condition, you can pretty much define it from this face here. So it's the flow of the pocket to this face, or the face down. You can go ahead and select the outer edge as well. It'll get you to the same end result here. So you can see here that it's being driven by the actual geometry, right? So when you make any changes or edits to the actual model, or the model changes, it's looking for these faces, and the toolpath will automatically update as the changes and updates happen there as well, right? So you get that full associativity. It's going to help you eliminate any errors and scrap when you're cutting these parts. Right, so we have the features generated, we have the operations generated, and we have the toolpath generated. So we can just go and simulate the toolpath now. So when you're simulating the toolpath here, you can change the colors and all that stuff, however you want to see things. I can slow this down and just go ahead and hit play. And it's actually machining away the stock. You can see the target part as it gets cut. And when you're doing this simulated toolpath here, you can choose different options for the collision. So you can have it cut the collision, ignore it, or pause collision if it's any collisions between the tool shank, the holder, right? All that. So you have full control over how you want to do this, how you want to show this simulation, right? So this would show you when you're going to be gouging your part, if that's something that it's going to do based off the parameters that you have set. So this will allow you to kind of visualize how this is getting cut on your machine when you actually go to post this out. Right, so once that's done simulating here, you can do this show difference and pretty much look at the part here and see if you've gouged excuse me, if you've gouged your part based off of the kind of colors that you see there, or if you have some features that haven't been cut or under machined, right? So yeah, that's the simulated toolpath. You can also play it with the next operation, so you can go operation by operation and see exactly what it's doing. If you have any lead ins, lead outs, you can go ahead and set that there to see how it's machining everything. And once you get that dialed in, then you can go ahead and post it. So right now, of course, you can see it's doing the roughing, the finishing, roughing, finishing. It's going to be doing a lot of tool changes because it's going from 3/4 to 1/2 inch here, right? You can sort out this tree by operation and group operations as well. So just a quick example of that. We can go ahead and sort this setup. We can sort it by operation type. So you can go ahead and adjust this. Say you want to do a face mill first and then do some roughing and then do your finishing there. And then sort it by tool, right? Now this here I'm just doing on the fly. In the database, you can create this sort scheme and load that sort scheme here, so you don't have to do this every single time, and you can customize it here, right? So go ahead and say okay, and you can see here did all the roughing and then the finishing here, right? You could also link all of these as well if you wanted to, and make changes to how SolidWorks CAM is machining these, right? So you have full customization over how you want to do that. So just for example, this rough mill one, we can go ahead and take a look at these parameters. Right, so you can see here it's using that 3/4 end mill. If I go to the roughing tab, it's doing this pocket out strategy. If you wanted to change that, you can go ahead and do something different. Let's say you want to do a spiral, hit preview, and then you can go ahead and see what that's going to look like. You could even simulate just that specific operation from here and see how that affects your model there when you make changes to these operation parameters. What's really great with this here is it shows you these graphic images of what it's doing, what's going on when you make any changes to any of these operational parameters, right? When you're looking at these depth parameters, it kind of gives you a visual, and also, of course, excuse me, you can pull up the help file, and the help file actually really is helpful as well, right? Just like the SolidWorks help is. So it's going to give you a bunch of these examples, what it's doing when you make these changes. So you might be looking at this 50 what, you don't see any units, that's 50% of the tool diameter. If you wanted to see the actual units there, you can click this button and you'll see those actual units there as well. So that's the operation parameters. You can go ahead and change these. I'll just go ahead and leave this spiral, hit preview. Let's click OK. Right. So that's making those operation parameter changes there. You can go ahead and simulate it one more time to play through the entire simulation. And once you know it's good, you can go ahead and post that out and post it. So how you would do that is you just go here and post process. It's going to use the post processor that you had selected when you were defining the machine. And it's going to go ahead and post that out. And what that did is it created a TXT file here that you can go ahead and post to your machine. Here's the code. All right, so you can run through this, take a look at that. You can use the NC editor to make any edits and changes to this G code as well. And it also creates a generic set file here, pretty much just a tool list here as well. All right. Okay, so that's kind of how you would program your parts. If you wanted to make any edits and changes to this, you can, right? By this, I mean the model, just to kind of show you how that's going to update. We can just go ahead and change this from 3.6 to 5. Let's say this is going to change to 4 inches. Right, rebuild the model, switch to your CAMWorks tabs. It'll automatically detect that change. Do you want to update the toolpath? Say OK. There you go. You can see the toolpath automatically changes to the sizes there. Right. Another great thing of being pretty much in the same software, right? SolidWorks, you can even use your SolidWorks sketches if you wanted to do any fixturing. You can sketch on this face, do something like that, and say, hey, this is going to be a clamp. So you can define that as an avoid area for that specific feature, and it would pull the toolpath out if it was going to hit that area there. So another benefit of kind of working in SolidWorks, right? We're all familiar with SolidWorks sketching and all the tools that come with SolidWorks. So you can use all those tools for SolidWorks CAM as well. All right, so let's go ahead and we just programmed that 2.5 axis part. Let's talk about downloading and importing parts from a vendor. So if we wanted to download some parts that we have lying around the shop, for example, Kurt Weiss's, you can go to their website or even 3D Content Central, right? You can go here and click on this. And these have CAD files here, right? So you can go ahead and download 3D format SolidWorks part assembly. You can go ahead and download that here, save that to your desktop. So what that's going to do is minimize that. You can see here that it has the zip file. We can go ahead and extract that. And I can open this in SolidWorks. Right, so this is what I'm talking about here with the FeatureWorks. Do you want to proceed with feature recognition? This technology was created by Geometric, which is the parent company of CAMWorks, right, which is what's powering SolidWorks CAM. So when you import a file from a vendor, whether it be MSC, Grainger, Chick Weiss's, Kurt, McMaster, so on and so forth, you have these files that come in here, a bunch of imported bodies, right? But you want this to be a usable assembly because you want to do some assembly machining using the SolidWorks CAM Professional, which is what we're going to get into here, right? If you import a file and it's got a bunch of solid bodies, you can right-click on that solid bodies folder and do a save bodies command. What this is going to do, you can go ahead and auto-assign names. It's going to save each of those individual part bodies because it's a multi-body part, right? Just imported single part file, bunch of imported bodies here. You can go ahead and save all of these bodies out and even create an assembly. So I can even create an assembly here. We'll just call this Kurt Weiss, like so. Save this out. It's going to save each of those bodies as a individual part file and then load them into an assembly here. And you can see here that we have the original part. So we'll switch to this here. So this is a Kurt Weiss assembly. Of course, everything is just going to be kind of imported, fixed in place in 3D space. So if you wanted this to be functional, we can go ahead and float the moving components. So if you wanted to find where these are in the tree, you can go ahead and do that, or just control select them like this, right? And then you can just say, hey, we want these to float. Now, since they're floating, you would have to go ahead and use the mates and mate everything up here and get everything going, right? So once you have all your mates set, then you can go ahead and move these around like that, right? So I'll just do a couple here just for the sake of time, right? You can go like that, make these coincident, right? And then this bottom face here, this face, make those coincident, and then probably apply a width mate or something like that here, right? Just forget about those fasteners right there. So this is now free to move, and then you can use this as your vise in the SolidWorks assembly. Now, just like a quick tip here, when you have this assembly, it requires all these individual part files. It's a lot of files to manage. You don't really need all that. So what you can do is shift select everything in the tree, right click, and then you can go ahead and make those virtual components. Now what that means, saving them as virtual components, it creates a copy and it saves, it saves these internally to the assembly file. So you can see it's got these brackets around the file name, meaning those are virtual components. So if I wanted to save this Kurt Vise, I can, and I don't need all the individual part files here that make up this assembly to go ahead and use this, right? So that's pretty much how I would go through and save these vices if you're downloading them from the vendors. So I'm just going to close that out here. I have the assembly that I want to show you, right? Pretty much with this part here as well. Close this out. Now here's an assembly of a vise that I have here, and the same kind of part that we were programming in the previous example here, right? So now we are in the SolidWorks assembly environment, and when you're doing assembly machining, that requires a SolidWorks CAM Professional. So you can see here, I have, of course, SolidWorks CAM Professional, and I can go pretty much through the same process and program this specific part on this vise. So the benefit of doing this here is you can set up, your fixture coordinate systems, work coordinate offsets, and also tell SolidWorks CAM that when you're machining this part here, you could avoid all your fixturing and all that stuff, and so on and so forth. So when you're programming an assembly machining here, similar process, you can go here and just define the machine, go through all that. Tool crib, set up the tool crib, choose your post. Once that's all set, then you can go here and select the part manager, and you want to manage your parts, right? So this is where you tell SolidWorks CAM the part that you are interested in machining. Say okay, that gets loaded here. Define the stock, right? So right now you can see there's the same 4 options here. If I had a plate where I'm machining a bunch of the same parts, you can do that from a common stock, individual separate stocks, so on and so forth, right? So we'll just go ahead and keep this simple. I won't add any offsets here. You can see I kind of have it floating off the top here of my jaws. So if you wanted to add that in the -Z, you can go ahead and add that that clearance there, right? Or add the additional stock so it's sitting right there. I'll just go ahead and run it like this, right? So once that's set, define the fixture coordinate system. You can go ahead and choose an entity wherever you want, right? If you're touching off your part, you can do that here too. Right, so here we are. There's my feature manager for this specific part, and I can go through here to find the setup and do all my features manually, or again, I can use that extract machinable features. Now, I didn't save the part. I should have from when I already programmed it because it was done, and all I needed to do, or all I would need to do if I had saved it, is import that CAM data from this part, because it's essentially the same file, right? Your CAM data lives in the SolidWorks file, and I can just right-click here and say import those the CAM information, and I'd have all my toolpath here, so you don't have to program it again, essentially, right? But I can just go here and say extract machinable features. Go through that same process. Right, so you'll see the features here. I set it to, it's set to detect, face features, and it's pink here because I didn't add any additional stock. So that's kind of one indicator right there, letting you know if an operation can't get generated, there's probably no stock to machine. So again, just those visual indicators letting you know, right? Then I can go here, generate the operation plan. Here's the operation plan here, and then generate the toolpath, right? So when you simulate this, all you're seeing right now is that plate. If you wanted to have SolidWorks CAM detect your vise or anything else in the assembly, you can just go here in the operation tab and then go ahead and define those as fixtures. So if you go through this and select all of these different components, right, all the fasteners, these guys here, and this here, right, we can go ahead and select all these. We can have it set to avoid. We can add all instances. Right, make sure you select everything. Now I can choose to avoid all of these, and that would do the collision detection and make sure that your toolpath doesn't collide with any of those. But I'll go ahead and uncheck that here because that can take some time to regenerate the toolpath there. Right. Then now when I simulate the toolpath, we should see our entire vise setup here when you go to machine this as well. Right. Then you can go ahead and do the show difference. And again, you're pretty much checking to see if you've gouged your part, how tight you're getting, if there's any areas that you need to go back in with a smaller tool, maybe sharp corners, so on and so forth. You can go ahead and use this simulation with the show difference, pretty much compare your finished part versus, or your target versus kind of how it's going to get machined here in the software or on your actual machine, right? So you can also set up your offsets as well. So you can go ahead and assign for the part setup origin. You can even do it off the corner of the stock and add and assign that offset so that your G54 regenerates the toolpath. There you go. And then you can go ahead and post this out, and then there's your posted code. Right. So that right there again is kind of how you would set up your part that you want to program in the SolidWorks assembly environment. We showed how to bring in imported geometry from Kurt, right? We downloaded Kurt Vise there. Came in as a multi-body part with solid bodies. We went to the save bodies, or the folder there for the bodies, the solid bodies folder, did a save bodies command, brought it into the SolidWorks assembly and floated it, mated it, and then that's kind of how you would go through this process here of setting it up, right? You could also model your table, everything. You can create custom tools, custom holders, make everything match exactly how it would in your shop for more accurate simulations and collision detection and machining, right? So that's pretty much it that I had to show you for the overview of the SolidWorks CAM. Not only the interface, but how to program the 2.5 axis part. Simple part, right? Did that very quickly, just a few clicks. Showed you how you can customize a few things. again, downloading the Vice and importing that there, and how to set that up into SolidWorks Assembly and program that using SolidWorks CAM Professional. Right? So I'll go ahead and open up to some questions here. But before I do that, let's talk about some upcoming webinars here. Of course, Webinar Wednesdays happens every Wednesday at 11. The topics that are coming up here in the following weeks is, PDM, the branching and merging functionality that's new in 2018, and also Damon's going to be talking about the SolidWorks simulation and plastics here as well. Okay. So again, thanks for attending. My name is Gabe, based out of the Mountain View, California office. So yeah, hope you enjoyed that presentation here. And again, I'll go ahead and open it up to some questions here. All right, everyone. So I'll stick around for a few more minutes here to address any other additional questions that come in. Again, thank you all for attending. Hope you enjoyed this presentation of the SolidWorks CAM and SolidWorks CAM Professional overview.